Welcome to this EWRB Electrical Service Technician Training course. I'm Aria, an electrical tutor working with Whitroy. In this course, I'll guide you through all the topics covered in the EWRB Electrical Service Technician Exam Teaching Guidelines. Welcome back. In our last session, we learned how to test and tag equipment safely. Now, we move to Topic 8.20, Commission and Decommission Equipment and Appliances. This topic is practical. It's about the correct, safe, and professional way to disconnect, reconnect, and test conductors when installing or removing electrical appliances and machines. We'll follow four main sections, Topic A to Topic D, exactly as set out in your EWRB Teaching Guideline. Let's begin with Topic A. Topic A, Procedures for Disconnecting and Reconnecting Conductors. Whenever we work on any fixed appliance or circuit, we must disconnect and reconnect conductors safely. This process follows the same logic as the lockout-tagout procedure from earlier topics, but now applied specifically to appliances and motors. Let's go step by step. Step 1. Isolation and tagging. Before disconnecting, always isolate the supply at the correct switchboard. Turn off the isolator or circuit breaker, lock it off with your personal padlock, and attach a danger tag showing your name, date, and contact. Then perform the prove, test, prove sequence. 1. Prove your tester on a known live source. 2. Test the circuit to confirm it's de-energized. 3. Prove the tester again to confirm it's working. Only when the test confirms 0 volts may you proceed. Step 2. Identifying conductors. As you disconnect conductors, label or mark each one clearly. Use identification sleeves or numbered markers for active, neutral, and earth. For three-phase circuits, also identify L1, L2, and L3, so you can restore the same phase sequence when reconnecting. Incorrect labeling leads to incorrect rotation or polarity later, so take your time here. Step 3. Making ends safe. Once disconnected, insulate all exposed conductor ends with tape or terminal blocks to prevent accidental contact. Bundle and secure cables so they can't be damaged or pulled back into conduits. If cables will remain unused, fit end caps or label them de-energized, do not use. Step 4. Protection and rotation. When reconnecting, check that your safety tag is still in place and isolation is still valid. Do another prove, test, prove. Then reconnect each conductor to its terminal, tightening the screws to the manufacturer's torque if specified. For three-phase motors, confirm correct direction of rotation by momentarily running the motor under supervision. If rotation is wrong, swap any two-phase conductors. Always test earthing, polarity, and insulation resistance before replacing covers and guards. In short, isolate, identify, make safe, reconnect, test and verify rotation. Topic B. Precautions when disconnecting or reconnecting different cable types. Now let's move to Topic B. Precautions for various cable types. Different cables require different handling to prevent damage or unsafe connections. Let's speak through the common ones listed in your guideline. 1. TPS, tough plastic sheathed cables, very common in fixed wiring. Avoid nicking the insulation when stripping. Keep the outer sheath under the cord grip inside the enclosure. 2. TRS, tough rubber sheath cables, older type, sometimes brittle with age. Handle gently, trim back cracked sections, and replace if insulation shows signs of perishing. 3. Neutral screened cables, used in some three-phase circuits. Ensure the screen is properly earthed and terminated under the clamp, not twisted into the neutral lug. 4. MIMS, mineral insulated metal sheath cables, used in high-temperature or fire-resistant applications. Keep bends gentle, use approved glands, and ensure the copper sheath is connected to earth. 5. Flexible cords and cables, found on portable appliances. Ensure the outer sheath is gripped, the conductors are not strained, and the earth is the longest conductor so it's the last to break if pulled. 6. Cables and conduit, whether metal or PVC, check that glands and bushings are fitted correctly and that earth continuity is maintained through metallic systems. 7. Copper-braided sheath flexible cables, used in welding and special tools. Inspect for frayed braid and ensure the braid is correctly earthed at terminations. Each type has its own hazards, so understand the construction and always re-terminate exactly as designed. Topic C. Correct identification and termination to maintain polarity. Now let's move to Topic C. Correct polarity. Polarity simply means the correct conductor is connected to the correct terminal, active to active, neutral to neutral, earth to earth. Under S/NZS 3000 Clause 2.3.2, every circuit must maintain correct polarity so that 1. Switches and fuses are in the active conductor only. 2. The neutral is never switched or fused, except in specific cases, and 3. The earth remains continuous throughout the system. If polarity is reversed, a switch might interrupt the neutral instead of the active, leaving the appliance body still live even when turned off. That's why every reconnection must include a polarity test using a meter or polarity indicator. In short, correct polarity means only the active is switched, and the metal parts stay safe to touch. Topic D. Consequences of interchanging conductors on a single-phase 230 V motor. Now for Topic D. What happens if conductors are interchanged? Let's go through each possible mistake one by one. 1. Active and neutral reversed. If the active and neutral are swapped, the motor may still run, but the switch and fuse could now be in the neutral conductor instead of the active. This means parts of the circuit remain live even when switched off, creating a serious electric shock hazard during maintenance. 2. Neutral and earth reversed. If the neutral is connected to the earth terminal, the metal body of the motor becomes energized whenever the circuit is live. Touching it could cause a severe electric shock. It also defeats RCD protection because the return path is no longer through the neutral conductor. 3. Active and earth reversed. If the active conductor is connected to the earth terminal, the entire motor frame and exposed metal parts become live at 230 volts. Any contact could be fatal, and protective devices might not operate immediately if fault impedance is high. These examples show why careful identification, polarity testing, and verification are absolutely essential before energizing. So remember this summary. Active and neutral reversed, dangerous switch position. Neutral and earth reversed, live frame. Active and earth reversed, deadly touch voltage. Always double-check connections before turning power back on. Applied example, disconnecting and reconnecting a single-phase pump motor. Let's finish with a practical example that brings topics A to D together. You're servicing a small 230-volt pump motor. You isolate the supply at the switchboard, lock it off, and attach your danger tag. You prove the circuit is dead using prove, test, prove. You mark the active, neutral, and earth conductors with colored sleeves before disconnecting. After completing the mechanical service, you reconnect each conductor to the correct terminal, tighten securely, and carry out 3 tests. 1. Continuity of the earth, less than 1 ohm. 2. Insulation resistance, greater than 1 megohm. 3. Polarity, switch and fuse in the active. You refit all covers and briefly energize to check rotation. The motor runs smoothly and safely. You record the results and remove your tag. That's a safe and fully compliant reconnection. Bringing it all together. Let's summarize Topic 8.20, Commission and Decommission Equipment and Appliances. We covered safe procedures for isolation, tagging, and identification of conductors, handling precautions for different cable types, the need for correct polarity, and the dangerous results of interchanging conductors on a single-phase motor. These steps are all part of commissioning and decommissioning under S/NZS 3017 and the Electricity, Safety, Regulations 2010. Checklist Summary. Here's a quick checklist to memorize. Isolate, tag, test, identify, reconnect, verify, record. Repeat it. Isolate, tag, test, identify, reconnect, verify, and record, every time. Summary. To wrap up, always isolate and lock out before disconnecting. Label all conductors as you remove them. Handle each cable type according to its material. Maintain correct polarity and verify before energizing. Understand the dangers of interchanging conductors. That concludes Topic 8.20, Commission and Decommission Equipment and Appliances. In our next lesson, we'll move on to Topic 8.21, Damp Situations and Wet Areas, where we'll explore protection methods, IP ratings, and special installation requirements for bathrooms, laundries, and outdoor environments under AS/NZS 3000 Section 6.